All right, we're going to go over absolute extrema today, and an absolute extremum is the highest point on a graph. So we'd call this y value the absolute max because it is the highest y value on that interval. This y value is called the absolute minimum. The absolute extrema don't always occur at critical numbers. They can occur at the endpoints. So here, critical numbers, this x value is a critical number, and this point is a critical point. And a critical point is where the slope is either 0 or undefined. So here the slope is undefined, and here the slope is 0, horizontal tangent line. Here we have absolute minimum. The y value is the absolute minimum. It's the lowest point on the graph, and that occurs at an endpoint. We can still talk about critical numbers and critical points, but on this graph there's no absolute maximum because the endpoint is missing and there's no highest y value there. So a critical number is where the derivative is undefined or 0, and absolute extrema occur at critical numbers or at endpoints. And that's how we're going to look for them without using a graph. So let's just review finding critical numbers before we find the absolute extrema. Critical numbers require the derivative, so we're going to go the first times the derivative of the second plus the second times the derivative of the first. And the first times the derivative of that plus the second factor times the derivative of the first. And if we distribute 2x cubed we want to know when g prime is 0 or g prime is undefined. That's where critical numbers can occur. So we want to know when the derivative is 0. Here we have a common factor. So x equals 0 or x equals positive or negative square root of 2. And a polynomial is never undefined. That's a polynomial. It's never undefined. So the critical numbers, we have 3 critical numbers on this function. And pause the video. Find the critical numbers for this function. We'll start with the derivative. And we have the denominator times the derivative of the numerator times the derivative of the denominator over the denominator squared. And distribute, we're going to combine like terms. We have negative 4x squared plus 4 and we want to know when f is 0 and when f is undefined. A rational function equals 0 when the numerator equals 0. So we'll subtract 4 and divide by negative 4. And we get a 1. So x is positive or negative 1. And the rational function is undefined when the denominator equals 0. And this gives us no critical numbers because it's imaginary. We would square root, subtract 1 and square root, and we get positive or negative I. So no critical numbers here. We just have positive or negative 1 for critical numbers here. Alright, so we need critical numbers first. We'll find the derivative, and we have 2x plus 2. Let's find critical numbers, and that's when f prime is 0 or f prime is undefined. And a polynomial is never undefined. Then we need to find the highest and lowest y values. So let's look at the endpoints, negative 2, the critical number, and then the other endpoint. So we have endpoint and critical number. These are the possible x values where there could be a maximum or minimum. But now let's remember that y is x squared plus 2x minus 4. We're not going to use the derivative. We need to use the function and substitute. Oops, that's negative 4. So we have 1. Minus 2 is negative 1, minus 4 is negative 5. This will be, well, let's finish. 1 squared, 3 minus 4, negative 1. So now we look for the lowest y value. That's the absolute minimum. And then the highest y value is the absolute maximum. Oh, and absolute is also, you could say global instead of absolute. All right, and pause the video, try that one. Derivative, critical numbers, that's when f prime is 0, f prime is undefined. So f prime is 0. At positive or negative 2, it's a polynomial, so it's never undefined. And then let's look at the y values. We need the endpoint 0, 2, and 4. So this is an endpoint, critical number. And it's going to be incorrect if we check, if we use negative 2. Negative 2 is a critical number, and if it gave us a maximum or minimum, we would have the wrong answer because we only can look at 0 to 4. So don't use the endpoint Don't use the critical number if it's not on the interval. And we'll use the original function. Now we have 0 cubed minus 12 times 0 is 0. If we put a 2 in there, we have 8 minus 24 is negative 16. And 4 is going to be 64 minus 48, and that's positive 16. So we have the absolute minimum and the absolute maximum. Okay, pause the video and try this one. Let's remember to rewrite it with an exponent, and then the derivative is 1/3 x to the negative 2/3, and that's going to be 1/3 cubed root of x squared. So the negative exponent gives it the reciprocal, and we're going to have the second power and third root. We need to know when the derivative is 0 and when the derivative is undefined. So a rational function is 0 when the numerator is 0. So this never happens because the numerator is never 0, and we can say the rational is undefined when the denominator is 0. Divide by 3, cube, square root, and we get 0. So at 0, the derivative is undefined. And these are critical numbers. Critical numbers are when the derivative is 0 or undefined. Okay, let's check endpoints and critical numbers. So the endpoints go from -1 to 1, and then we have a critical number on the interval. Let's use the original function, and we have the cubed root of -1 is -1. The cubed root of 0 is 0. Cubed root of 1 is 1. And we have the absolute minimum and absolute maximum. Pause the video and try this one. We need the derivative. And that will be the denominator times the derivative of the numerator times the derivative of the denominator over the denominator squared. And the critical numbers are when f prime is 0 or f prime is undefined. A rational is 0 when the numerator is 0. And a rational function is undefined when the denominator is 0. No critical numbers from that. And we check the y values on the interval -2 to 2. We have both of the critical numbers are on the interval. So then we substitute those into the original function. If we put a -2 in there, we get -4/5. Put a -1 in, we get -1. And a 1, we get 1. 2, we get 4/5. So we'll say that the -1 is the absolute minimum, and +1 is the absolute maximum. And we'll stop there.